Welcome you all in lecture of Computer Communication Network. I, Miss Mayuri Harade, Assistant Professor in Electronics and Communication Engineering Department, Tulsiramji Gaikwad Patil, College of Engineering, Nagpur. Congestion control algorithms. Congestion means the situation in which too many packets are present in the subnet. Graph between packets sent to packets delivered. Causes of congestion. Congestion occurs when a router receives data faster than it can send it. Insufficient bandwidth, slow host, data simultaneously arriving from multiple lines, destined need for the same outgoing line. The system is not balanced. Correcting the problem at one router will probably just move the bottleneck to router. Congestion causes more congestion. Incoming messages must be placed in a queues. The queues have a finite size. Overflowing queues will cause packets to be dropped. Long queue delays will cause packets to be resent. Drop packets will cause packets to be resent. Senders that are trying to transmit to a congested destination also becomes congested. They must continually resend packets that have been dropped or that have timeout. They must continue to hold outgoing unacknowledged messages in a memory. Congestion control versus flow control. Flow control means controls point-to-point traffic between sender and receiver. Example, a fast host sending to a slow host. Congestion control controls the traffic throughout the network. Two categories of congestion control: open loop solutions and closed loop solutions. In open loop solutions, attempt to prevent problems rather than correct them. Does not utilize runtime feedback from the system. Closed loop solutions uses feedback measurements of system performance to make corrections at a runtime. Transport layer. Fourth layer of OSI function. Demultiplexing of data streams. Optional functions are creating long live connections, reliable in order packet delivery, error detection, flow and congestion control. Key challenges: detecting and responding to congestion, balancing fairness utilization. The case for multiplexing. Datagram network, no circuits, no connection. Client run many applications at the same time. Who to deliver packets to? IP header, protocol field 8 bits is equal to 56 concurrent streams. Insert transport layer to handle demultiplexing. Then layering revisited. Lowest level end-to-end protocol. Transport header only read by source and routers view transport header as payload. UDP, user datagram protocol. Simple connectionless datagram. Port number enable demultiplexing. 16 bits is equal 65535 possible ports. Checksum for error detection, detects some corrupt packets and does not detect drop or duplicate packets. Uses for UDP. Invented after TCP. Not all applications can tolerate TCP. Custom protocols can be built on top of UDP. Examples: RTMP, real-time media streaming, and Facebook data center protocol. TCP, transmission control protocol. Reliable, in order, bidirectional byte streams. Port numbers for demultiplexing, virtual circuits, flow control, and congestion control. Why do we need connection setup? To establish state on both hosts. Most important state: sequence number, count the number of bytes that have been sent, initial value chosen at random. Important TCP flags are synchronization, acknowledge, and finish. Thank you.